Compressor Handbook: Principles and Practice. This book examines the full spectrum of compressor types, how they operate, how to control them, and how operating conditions can significantly impact their performance. Discussed in detail are the influence of pressure, temperature, molecular weight, specific heat ratio, compression ratio, speed, and position, and volume bottles. The various methods of throughput control are also addressed, including discharge throttling, suction throttling, guide vane positioning, volume bottles, suction valve unloaders, and speed control, as well as how each of these control methods affect compressor life. Compressor surge is defined and discussed in detail, along with the available type of instrumentation, controllers, valves, pressure and temperature transmitters, and which of these are most suitable for controlling surge. Case studies are included to illustrate the principles covered in the text. Two types of dynamic compressors are used in today. They're the axial compressor and the centrifugal compressor. The axial compressor is used primarily for medium and high horsepower applications, while the centrifugal compressor is utilized in low horsepower applications. Both the axial and centrifugal compressors are limited in the range of operation by what is commonly called a stall or surge and a stonewall. The stall phenomena occurs at certain condition of flow, pressure ratio, and speed, which result in the individual compressor airfoil going into the stall, similar to that experienced by an airplane wing at a high angle of attack. The stall margin is the area between the steady state operating line and the compressor stall line. Surge or stall will be discussed in detail later in this chapter. If the speed of the airfoil relative to the gas is too high, a shock will develop as the gas exceeds the speed of sound, trying to accelerate as it passes around the airfoil. They're gonna do more interviews, bastards. Stall characteristic curve stall width. Fuck.